C-number programming language. What is C-number, C-sharp? A general-purpose, high-level, multi-paradigm programming language, C-number, pronounced C-sharp, was developed. Programming paradigms like imperative, declarative, functional, generic, object-oriented, class-based, lexically scoped, static typing, strong typing, and component-oriented are all supported by C-number. Microsoft employee Anders Hejlsberg created the C-number programming language, which was eventually recognized as a global standard by ECMA 334, in 2002 and ISO/IEC 23270, in 2003. Microsoft unveiled C-number along with the closed-source .NET Framework and Visual Studio. Microsoft didn't have any open-source products at the time. A cross-platform compiler and runtime environment for the C-number programming language were made available by the free and open-source project Mono 4 years later, in 2004. A decade later, Microsoft launched the unified .NET Platform, Software Framework, Roslyn, Code Editor, and Visual Studio Code compiler, all of which support C-number and are free, open source, and cross-platform. Mono joined Microsoft as well, but it was not incorporated into .NET. The most recent stable version of the language as of November 2022 is C-number 11.0, which was made available in 2022 with .NET 7.0. History and development. The class libraries were initially created during the development of the .NET framework using a managed code compiler system named Simple Managed C (SMC). Anders Hejlsberg established a team in January 1999 to create a brand new programming language at the time known as COOL, which stood for C-like Object-Oriented Language. Microsoft had contemplated using COOL as the language's final name, but decided against it due to trademark concerns. The language had changed to C-number by the time the .NET project was made public at the Professional Developers Conference in July 2000, and the class libraries and ASP.NET runtime had been converted to it. Hejlsberg was a key figure in the development of Turbo Pascal, Embarcadero Delphi, formerly CodeGear Delphi, Enprise Delphi, and Borland Delphi, and Visual J++, before becoming the chief designer and lead architect of C-number at Microsoft. He has claimed in interviews and technical papers that shortcomings in the majority of popular programming languages, such as C++, Java, Delphi, and Smaltic, served as the inspiration for the Common Language Runtime, CLR, which in turn served as the basis for the creation of the C-number language. Bill Joy, a co-founder of Sun Microsystems, the company that invented Java, and James Gosling, the creator of the Java programming language, referred to C-number as an imitation of Java. Gosling added that C-number is sort of Java with dependability, productivity, and security eliminated. Java and C-number are nearly identical programming languages, according to Klaus Kreft and Angelika Langer, authors of a book on C++ streams, who said in a blog post, "Boring repetition that lacks creativity." Hardly anyone will assert that Java or C-number are groundbreaking programming languages that altered the way we create programs, and both C-number and Java borrowed heavily from each other. We'll have a capability quite similar to boxing and unpacking in Java, now that C-number enables it. Hejlsberg said that C-number is not a Java clone, and that its architecture is far closer to C++ in July 2000. Since the November 2005 release of C-number 2.0, the development paths of C-number and Java have become increasingly divergent, resulting in two quite different languages. The introduction of generics to both languages, with radically different implementations, was one of the first significant changes. Reification is a technique used in C-number to create first-class generic objects that can be used in the same way as other classes, with code generation taking place at class load time. Additionally, C-number has added a number of significant features to facilitate functional-style programming, the most notable of which being the link extensions included in C-number 3.0, together with the framework of lambda expressions, extension methods, and anonymous types that it supports. When it benefits their application, these characteristics let C-number programmers use functional programming approaches like closures. With the help of the link extensions and functional imports, developers can focus more on the actual program logic to increase readability and maintainability by reducing the amount of boilerplate code used for routine tasks like querying databases, parsing XML files, and searching through data structures.